Hello and welcome to Chord Properties 8 and 9 in circle geometry. I'll discuss in this video two more theorems we are expected to be able to prove which are the converse of each other. Theorem 8 says that if we have equal chords in a circle, then they will be equidistant to the center. So let's prove it. We want to prove that OP equals OQ. This will prove they are both the same distance from the center. The only information we have is that the two chords AB and CD are equal to each other. And because we're going for the shortest distance between the center and the chords, we know that OP is perpendicular to CD and OQ is perpendicular to AB. We will need to join OA and OD together to form two triangles, which we will try to prove the two sides, OP and OQ, are equal to each other. We start by saying that Q is the midpoint of AB, because from our last theorem we know that the perpendicular lines from the center to a chord will bisect the chord. Similarly, P is the midpoint of CD. Therefore, AQ is equal to BQ, which is equal to DP, which is equal to CP, because AB equals CD from our data. Now we start our congruence proof. In triangle AOQ and triangle DOP, we know that AO is equal to DO because of equal radii, AQ is equal to DP, as we proved above, and angle AQO is equal to angle OPD, which equals 90 degrees, because OQ is perpendicular to AB and OP is perpendicular to CD. Therefore, triangle AOQ is congruent to triangle DOP because of RHS. Therefore, OP equals OQ, and we can say that because matching sides in congruent triangles are equal, proving our theorem. The converse of theorem 8 states that chords in a circle which are equidistant from the center will be equal in length. So let's prove it. We want to show that the chords ST and XY are equal to each other if we know that OB and OA are perpendiculars to the chords XY and ST respectively. Remember, perpendiculars are the shortest distance from the center to a chord. The other thing we know from our theorem is that the two lines OB and OA are equal to each other, or they're equidistant. Again, we will need to construct OX and OS to create two triangles we can use congruence to prove that they are equal. So, in triangle OBX and triangle OAS, OX is equal to OS because of equal radii, OB is equal to OA as given in our data, angle OBX is equal to angle OAS, which equals 90 degrees, because OB is perpendicular to XY and OA is perpendicular to ST. Now we can say that triangle OBX is congruent to triangle OAS because of right angle hypotenuse side. Therefore, we can state that BX equals AS because matching sides in congruent triangles are equal. From here I state that B is the midpoint of XY. And I know this because of theorem 7 and 8, which states that the perpendicular distance from the center to a chord will bisect the chord. Excuse me while I move this line of working out to a new page. Yeah, that's better. Now, because B is the midpoint, this means that the chord XY is twice the length of BX. Similarly, A is the midpoint of ST, making the chord ST twice the length of AS. We can now draw our proof to a conclusion by stating that ST has to equal XY, as we have already proved that BX equals AS and the two chords are both twice the length of these lines, proving our theorem. We will now attempt an example using the two theorems we've just proven. This example says that AP and AQ are two chords of a circle with a center O. We also know that AB is a diameter. If we know that the angles PAB and QAB are equal, then we have to prove that AP is equal to AQ. At this point, you should pause the video and try to attempt the question yourself. Here's a hint. Construct a line from the center to both chords, which will be the midpoints of the chords AP and AQ. Good luck. Okay. Like I said, we're going to start by letting M and N be the midpoints of AQ and AP respectively. And I will join OM and ON to create two triangles. From this I know that OM will be perpendicular to AP, because the line from the center to the midpoint of a chord is perpendicular to the chord. Similarly, I know that ON is perpendicular to AQ. Here's the proof. In triangle OMA and triangle ONA, OA is common, angle OMA is equal to angle ONA, which is equal to 90 degrees, as we've proved above, and angle PAB will be equal to angle QAB, which is given in the question. Therefore, triangle OMA is congruent to triangle ONA because of angle side. This means that AM equals AN because corresponding sides in congruent triangles are equal. But AP is equal to 2 lots of AM, as AM is the midpoint, and AQ is 2 lots of AN because N is the midpoint. Therefore, AP has to equal AQ, as AM is equal to AN and the two chords are both twice these lines. Proving our question. In our next video, we will look at how to find the center of a circle and learn new mathematical language to use in our proofs. Thanks for watching.